Okay, today we're going to talk through the rest of this lesson. We're going to talk mostly about the quadratic equation or the quadratic formula, and then identifying whether solutions are real or non-real. We're still going to have complex solutions, and we're still going to work on our reasoning techniques. All right, so by completing the square for the general quadratic equation, so if we actually went through and completed the square on this, we would obtain the quadratic formula. So this right here, you might want to circle, bold, underline something. That's your quadratic formula. Which gives the solutions of the general quadratic equation. In the quadratic formula, the expression under the radical sign, b squared minus 4ac is called the discriminant, okay? So this thing here is the discriminant. And its values determine whether the solutions of the quadratic equation are real or non-real. So this chart tells us the values. If it's greater than 0 or positive, you have two real solutions. If it's equal to 0, there's one real solution. If it's less than 0 or negative, there are two non-real solutions or two imaginary solutions. All right, so we're going to see that. They're going to put it in the context of word problems, but the arithmetic we're going to do is the same as what you would do if you were just asked to find the value of the discriminant, which they do in the homework. So it says, answer the question by writing an equation and in determining whether the solutions of the equation are real or non-real. So a ball is thrown in the air with an initial velocity of 14 meters per second from an initial height of 2 meters. The ball's height, h in meters, at time t in seconds can be modeled by the quadratic function. So they gave it to us. Does the ball reach a height of 12 meters? So in order to figure that out from the discriminant, they have to be real numbers. If you get non-real numbers, then it's not possible for the ball to ever reach that height. Okay, because if it reaches that height and we have one real solution, we know it got to that maximum point. It actually equaled that height. If it has two real, and we know it had to go all the way up and come back down, so it should reach that height as well. All right, so first thing they're going to do is they're going to take their function, set it equal to the height that they want. So that's what they did in this first step here. Then they subtracted the 12 from both sides. So we get 10. They got a positive 10, and they should have gotten a negative 10, huh? I think there's a typo right there. It should have been a negative 10. Let's see what it says in my book. It still says a positive 10. Okay, let's see what they do with it from there. Then the value of the discriminant, remember, it has to go in the formula negative b minus 4a, or sorry, b squared minus 4ac. I don't know why I'm saying negative b. B squared minus 4ac. So it has to go in the formula b squared minus 4ac. Okay. And remember that this is the a, that's the b, and this is the c. All right, so they put in the b squared. So 14 squared, I agree with that. Minus 4 from the formula. A was the negative 4.9. And interestingly enough, they actually used the negative 10. So the sign is correct here. It was incorrect in that line right there. Then they went ahead and they did the arithmetic. 14 squared is 196. And when they multiplied this out, you can use your calculator. That's fine. They got 196. 196 minus 196 is 0. So because the discriminant is 0, the equation has one real solution, so the ball does reach a height. So it does actually get to the height of 12 meters. If you were just asked to find the value of the discriminant, you're just going to use these steps right here. All right, so a person wants to create a vegetable garden and keep the rabbits out by enclosing it with 100 feet of fencing. The area of the garden is given by this function, where W is the width in feet in the garden. Can the garden have an area of 700 feet squared? So we basically take our area function, set it equal to 700. They distributed that W through. Okay, and then they're going to bring this 700 to the other side by subtracting, so it'd be minus 700. And they want us to find the value of the discriminant. Again, it's A, B, C. Okay. So to find the value of the discriminant, we would do b squared, so 50 squared minus 4, times a, which is the negative 1, times c, which is negative 700. Okay. Make sure I'm doing my arithmetic right here. Okay, so 50 squared is 2,500. When we multiply -4 times -1, you're going to get +4 times -7 is going to be -2,800. And so we end up with a -300. So because the discriminant is negative, the equation has two non-real solutions, so the garden cannot have an area of 700 feet. So the only time we're going to have the cannot is when we have the two non-real or the two imaginary solutions. So that's when they want us to do all on our own. A hobbyist is making a toy sailboat. For the triangular sail, she wants the height in inches to be twice the length of the base. All right, I need a triangle. So the height, so the base, we're just going to call B. The height is supposed to be twice the length of the base, so 2B. We need to actually write our own equation. So formula for area of a triangle we know is 1/2 the base times the height. So I would see 1/2 the base, which is B, times the height, which is 2B. So those 2's are going to cancel. So my area is just B squared. Then we're going to set that equal to this. Can the area of the sail be 10 inches squared? So you're going to say B squared equals 10. I'm going to try to put this, I'm going to get it equal to 0 so I know what my A, my B, and my C are. Even though I used a B there, we're still going to have our A, B, and C value. So B squared minus 10 equals 0. So if we're thinking about A, B, and C now, we really have B squared plus 0 B's minus 10 equals 0. So there isn't an actual B value. So this, according to our little formula, the A would be the 1 in front, the B would be the 0, and the C would be the 10. So if I'm going to do the value of my discriminant, I do 0 squared minus 4 times A, which is 1, times C, which is -10. The 0 goes away. -4 times 1 is -4, times -10 is 40. So it's because it's positive, it has two real solutions. So because discriminant is positive, equation, sorry, too fast, equation has two real solutions and the area can be 10 inches squared. As long as you get it being a real solution somewhere, at least one, you can have whatever the area or whatever the answer is. Okay, so now, I don't know why there's ink on here. Let's see if it'll erase. Oh, there we go. Okay, now we're going to actually use the quadratic formula to solve, and then they do this insane thing where they substitute in the values to check. We'll talk through it on this one, but I'm not going to do it on any of the others. So in order to use the quadratic formula, it does have to be equal to 0, and I know this should be review, except that there are going to be i's in it now. We're still going to use A, B, and C. So you don't have to write out the quadratic formula, but I do want to see you writing it out and substituting it in this formula until we get through the assessment on it, okay? So we got -b, so our b value is -2, so that gets substituted in, plus or minus the square root of -2 squared minus 4 times a, which is the -5, times c, which is the -8, all over 2 from the formula times a, which is -5. All right, so when they do the arithmetic on this, the double negative is going to go positive. So that gets you your 2. -2 squared is 4, and then we multiply all that together. So you get positive 20 times 8, which is negative, ends up being -160. So 4 minus 160 is -156. They skipped a whole bunch of steps, didn't they? I'm going to show you the steps over here. So you've got 2 plus or minus. I see a negative under a radical sign. Remember, that means we pluck our i's out. Okay. And 156, my guess is simplifies a little bit. I know that 4 goes in there, so let's try 4. 4 goes in there, let's try, I think 39 times. 4 times 3, 36. Yeah, so 4 goes in there 39 times. Square root of 4 is 2. And I know that's written really, really weird and backwards. Now, notice they've got it reduced here. Okay, so there's a couple of ways you can do this. Either you can factor a 2 out, or a lot of students like to split up the fraction. So I'm going to show you the split up the fraction, and then you can choose. Oops, shouldn't be over 39, should be over 10. This is a spot where they skipped too many steps over the negative 10. So this is going to reduce to 2 goes into 10 5 times, so negative 1/5. And then the minus here is just going to make that opposite signs. It'd be minus plus, so it really doesn't matter. The 2 into the 10 again 5 times, so I square root of 39 over 5. You can leave it separate fractions, or you can put it back over one single fraction. Okay. So there are technically 2 solutions, okay? There's one with a plus in it, one with a minus in it, and then what they did was they tried to simplify it. They put it back into this equation here. So they put in this ugliness for the that ugly number for the x's, which I think is a little bit insane. Then they basically, when you square something, remember that you FOIL it. So you take this and you multiply it by itself. That gave us this ugly mess. Then they looks like here they distributed in the negative 5, and here they distributed in the negative 2. They got it to this point, which means we could start combining like terms. It looks like those cancel. And then they have, let's see, they did the fifths. So negative 1/5 and positive 2/5 is 1/5. Plus 39 is 40/5 minus 8. 40/5 reduces to 8, so 8 minus 8 is 0. So it did check out. Okay. If you want to go through all of that, you can. At least let's try solving and getting the quadratic formula reduced. Okay. So I'm not going to show these steps here. We're just going to get the 2 solutions. Okay. Rather you do the simplification. So the first thing we have to do is get it equal to 0. So this one's not equal to 0. And anytime we solve a quadratic, that's what we want to do, is get it equal to 0. So I'm going to add 1 to both sides. So that gives me a 4 here. So my A is 7, my B is 2, and my C is 4. So we now substitute in. So we're going to put in the B, so negative 2 plus or minus 2 squared minus 4AC, so 7 times 4 all over 2 times A, which is 7. All right, so the negative 2 is going to stay negative 2. This is, underneath the radical sign, it would be 4 minus, let's see, 7, or 4 times 4 is 16 times 7. I'm going to check my handy calculator, sorry. I want to make sure I get it right. 7 times 16, 112. And then 112 minus 4 is negative 108 is what they're going to have in there. So they kind of skipped over that step. And then 2 times 7 is 14. Again, they're skipping a bunch of steps here. So I'm going to do my work over here, and then we can fill their stuff in. So we've got negative 2 plus or minus. When I see a negative under the radical sign, I pluck my eyes out. The biggest square number that goes into 108. I know 4 goes in there, but I'm going to keep trying things. 9 also goes in there. If 4 and 9 go in, then 36 is likely to go in. So you remember to do my little trick with the can and the can't do box, you have to pull out the biggest square number. And it goes in there 3 times. Still over 14. The square root of 36 is 6, so that's what they would have put in their little blanks here. I would have normally just done this all in one line. 6 square root of 36 is 6. I square root of 3. And then, see, I would have come out here and done another step. I know this is kind of crazy. I would have probably split that into 2 fractions. So 2 plus or minus negative 2 over 14 plus or minus 6i squared of 3 over 14. 2 goes into 14 7 times. So I have negative 1 over 7. Oops, sorry. Okay. And then 2 goes into both 6 and 14, so this is going to be 3 and 7. So plus or minus 3i squared to 3 over 7. And again, you can always rewrite it as one single fraction when they have a common denominator, which is what they would have filled in there. All right, so we're going to take a turn and try this. Again, I'm not going to do the check. It's up to you whether or not you do the check. So we're going to solve it using the quadratic formula, and we aren't going to have to go back and forth. I can keep my work all in one line. So I've got my A, my B, and my C. So we've got negative b, which is negative 5, plus or minus square root of negative 5 squared minus 4 times my a, which is 6, times my c, which is negative 4, all over 2 times 6. All right, the double negative is going to go positive. Negative 5 squared is 25. 4 times 4 is 16, times 6 is 96, and it'd be positive 96, all over 12. 25 plus 96 is 121, all over 12. All right, so this one is really different because it's going to come out with an actual nicer looking answer. Square root of 121 is 11. I cannot leave my answer like that because I can get a numerical answer. So the way we deal with that is we split it into two. We've got 5 plus 11 over 12 and 5 minus 11 over 12. 5 plus 11 is 16 over 12. 4 goes into both of those, so that one comes out to be 4/3. 5 minus 11 is negative 6 over 12, which 6 goes into both of those, so it reduces to negative 1/2. Something like that would be more reasonable to plug in and check. Now, on this one, remember, we've got lots of ways to solve quadratics. When it came out to answers like this would have been factorable with a magic X in a box, okay? So I would have probably tried factoring it first if I had a choice of the way I did the problem. Quadratic formula is best used when it's ugly and going to have i's and radicals and all those kind of things in it when it doesn't factor. That's usually the second thing I do. I do factoring first, then I do quadratic formula, and then if all else fails, I'll complete the square. We're going to, again, solve it with the quadratic formula. I got to move this over. This time it's not just a number. It's actually a 2x. So remember, we got to combine it with its like term. So we've got x squared plus 6x plus 12 equals 0. I've got my a value, my b value, and my c value. Again, we're practicing quadratic formula. So we've got negative b, which would be negative 6, plus or minus square root of the b squared, which is 6 squared, minus 4 times the 1 that's in front of the x squared, times c, which is 12, all over 2 times the 1 in front. And yes, I want you to write it out even with the 1s right now. Excuse me. So you got negative 6 plus or minus square root of 6 squared is 36. Negative 4 times 1 times 12 is negative 48, all over 2. Negative 6 plus or minus square root of 36 minus 48 is negative 12 over 2. All right, I see a negative under the radical sign, which means I'm going to pluck my i's out. And then I need the biggest square number that goes into 12, which is 4, 3 times. We've got negative 6 plus or minus, the square root of 4 is 2i, square root of 3 over 2. If you want to go ahead and just split it into two fractions there, that's fine. 2 goes into 6, negative 3 times. 2 goes into 2 once, so I square root of 3. All right, I think that does it for us for today. If you did not get 11 done yesterday, you should be able to do it today and then get 12 done. And that gets you your class points for the day, and then you can start working on the homework.